One integer is 5 less than the other. Their product is 84. Find the integers. This problem, we have two integers which are unknown. Let's try to represent these two numbers using some variables. Of course, we only have to use here one variable. We start by representing the independent quantity. The independent quantity based on this statement, one integer is 5 less than the other, is of course the other, right? These two integers are described using these words. One integer is one of the description for the integer, and then the other, of course, is the other, right? So what are this other and one integer? We have to use these descriptions because this was used in the problem. Now we have to represent x first using the independent quantity, which is the other quantity. So let's say let x be the other integer. If x is the other integer, then that means one integer is what? Since one integer is described as 5 less than the other, there's one operation involved here, and that is less than. Okay? Less than means minus. And how do we represent 5 less than the other? If you represented other as x. Representing other as x will give us this expression for this one integer. 5 less than the other will be x minus 5. So let x minus 5 be one integer. All right? That is your x minus 5, that's one integer, and x, of course, the other integer. Right? So here we have that. X is other, and then one integer is this 5 less than the other. Let's find the equation for this problem. And what equation can we form out of this? If it says their product is 84, what do we mean by their? What are these there? What are we referring to? These are your two integers, right? Their product is 84. Their product would pertain to the product of x and x minus 5. So we can write that here. Their product, of course, that is x times x minus 5. And that's equal to, is means equal when translated to mathematical symbol. Is means equal. And of course, that is 84. Right? Their product is x times x minus 5, is means equal, and that's 84. So it's very important to represent these two numbers as x and x minus 5. Now let's solve this equation. We have x times x minus 5 equals 84. And the result would be quadratic, but this one is not in standard form, so we have to write it in standard form. By using distributive property, we can make that standard. X times x, x squared. How about x times negative 5? That's negative 5x. So we write down x squared minus 5x equals 84. But notice that this one is not in standard form because our right side is 84. We make that 0 by subtracting both sides by 84. Minus 84. And if we look at these three are unlike terms, but we cannot combine them. We simply try to write. Just copy each of the term. We have x squared minus 5x minus 84 equals 0, because 84 minus 84 is 0. And now it's a quadratic equation in standard form written in ax squared plus bx plus c equals 0. So in that case, what are the factors of negative 84 whose sum is negative 5? Where did we get that? This is your negative 84 product, and the sum is negative 5, the coefficient of x. Since we are factoring a negative number, that means that the signs of our factors should be negative and positive. But what are these numbers? Negative and positive numbers whose sum is negative 5. We can try out all those numbers, right? So let's try to write them here. If we are factoring a negative number, negative 84, our sign should be negative positive. So let me just put negative on the left and the positive on the right side. Negative, positive, negative, positive. Think of a number that divides 84. 12? 12 then? 7. All right. So if this is 12, negative 84 divided by negative 12 is 7. Wow. I think that you've got the correct factors now. Do we still need to try out other numbers? I think this is it. Negative 12 plus 7 is negative 5. So that means that we don't have to think of other numbers. Well, this step is optional. You can do it. You may or may include that in your solution. You may or may not, I should say. May and may. So we have negative 12 here, positive 7. Is it safe to write x minus 12 and x plus 7 now? Yes, because we don't have a coefficient for x squared. So it's safe to write x minus 12 and x plus 7. So our factors here would be x minus 12 times x plus 7 equals 0. Solving for x here, we have to set each factor to 0. X minus 12 equals 0, or x plus 7 equals 0. Solve for x in each of the equation. Okay, plus 12 here. Now we have x, which is equal to positive 12. How about the other one? We have x minus 7. When x plus 7 equals 0, minus 7 both sides, we have x equals negative 7. Now both are integers. Since we are looking for two integers, then we can accept both, 12 and negative 7. But it doesn't mean that those two numbers are 12 and negative 7. These are only the values of x. In order to find the other numbers, remember that in our step 1, we represented x as the other integer. So both of these 12 and negative 7 are your other integer. So what is that one integer there? In order to solve that, we have to evaluate x minus 5. So evaluate x minus 5 using both values. So what's x minus 5 here? So x is 12, right? So we replace x by 12. Now this is one of, this is one of the integers. So what is the other one? Well, your x is 12 here. So that means we have to do 12 minus 5, which is what? 12 minus 5, 7. So these are your two numbers now. 12 and 7. That's one possible pair. And the other possible pair of integers would be negative 7 and the value of x minus 5. So let's look at that value. Again, we have x minus 5 here. Of course, Negative 7 is your x. Negative 7 minus 5. Now what's negative 7 minus 5? Negative 12. So we have x minus 5, negative 12. So this is another pair. We can consider these pairs because both pairs are integers. There's no other condition. We are only asked to find for the integers. It did not ask for a positive integer or a negative integer. So we can have both pairs. Therefore, what is our answer in this problem? There are two answers in this problem. Let's put our answers now. These are 7 and 12. And the other one is negative 7 and negative 12. All right. So these are your possible pairs of answers. Negative 7, negative 12, and 7 and 12. I think we're done there.